Good afternoon and welcome everyone. I'm Ross, Virginia. I'm a faculty member in the Environmental Studies program here, but I also direct the Institute of Arctic Studies, which is part of the Dickey Center for International Understanding. And I want to thank you. This is a great turnout. Thank you for being here, and I know you won't be disappointed by today's presentation. We're honored to have Dr. Stephanie Pfirman with us today. And she's the professor of environmental science and co-chair of Barnard College's Department of Environmental Science. She's also the Hirshhorn Professor of Environmental Science and co-chair of Barnard College's Department of Environmental Science. And there's a whole bunch more appointments coming here. She holds a joint appointment with Columbia University, where she's a member of the faculties of the Earth Institute and the Department of Earth and Environmental Sciences, and also adjunct research scientist at Lamont Doratory Labs at Columbia University. And almost every one of these appointments reflects a different aspect of the way she approaches trying to understand the Arctic, the natural world, and how we're changing that. Her scientific focus is on the Arctic environment, and in particularly trying to understand the dynamics and behavior of sea ice. She's clearly one of the world's authorities in this area, and there's quite a few sea ice enthusiasts in the audience, so I think we'll have some good questions coming up. She's co-chaired a number of very important studies for the National Academy of Sciences and other groups advising policymakers in the government. Perhaps the most recent and very important topic is the study on emerging research questions in the Arctic, which was produced as the Arctic in the Anthropocene report. She's a fellow in the American Academy, or the American Association for the Advancement of Science, and has had many other awards for her work. In looking and knowing her work, and when you look at her resume and go to her website, it's quite remarkable. And she is an environmental scientist, but I think, to me, she's really an interdisciplinary scholar. Her work spans across sciences into social science, into policy, into science communication. We were talking about the arts today. And issues around women and gender and science. All these topics are equally important to her. I think one of the things that she's very engaged in right now is this topic of science communication, and she heads a very large NSF-funded project called Polar, and it's really about climate change education partnerships. How do we form them? How do we engage scientific communities, and how do we share that information with the public? Games are very important to this effort. She met today with the Tilt Factor game group, the digital humanities people here at Dartmouth. And we shared a lot of interest and information about how games can be used to impart information, but also to expose attitudes about environment, gender, and other kinds of cutting-edge problems. So these are the issues that are dear and dear to Stephanie's research. She was also very active and was a co-principal investigator of a very influential program called Advance. Advance took on the challenge of how do we engage diverse communities and more women in the so-called STEM pipeline, science, technology, engineering, and mathematics. And she's traveled around the country and the world into many international meetings, championing diversification of science and making these opportunities more transparent to all. Early on, she worked in the House of Representatives and as staff scientist with USGS, and I think those experiences allowed her to really take on the challenge of connecting science to policy, and in particular, the importance of evidence-based decision-making around the environment and around society. And I think everyone in this room realizes just how important that is today to get that right. Her PhD is from MIT, Woods Hole Oceanographic Institution Joint Program in Oceanography and Oceanographic Engineering. I should say this is her third visit to Dartmouth. Her very first visit was here during the Arctic Science Summit Week as a member of the National Academy's Polar Research Board. And every time she's here, we work her very hard. Her schedule in the next 2 days is really pretty remarkable. She's already met with a number of faculty in Arctic and polar research, and that continues through the whole stay. She's meeting right after this with the Dickey Center's Great Issues Scholars Program for first-year students, meeting with the Graduate Women in Science and Engineering, the first-year Women in Science Project, the Joint Science Education Project, the Dartmouth Center for the Advancement of Learning, And then finally, she's also meeting, I think, with a number of administrators here at Dartmouth to engage them in the challenges that face the Arctic and interdisciplinary scholarship. So it's great to have you back. Thank you so much for being here, and a warm welcome for Dr.
Thanks so much, Ross. I really appreciate that generous introduction. You were able to navigate my complex career trajectory very nicely. I think I have to bring you in to kind of introduce me in the future. It makes a lot more sense when you describe it than when I try to do it. So I'll be talking here today about the once and future Arctic. Looking ahead, all projections are that we'll be moving from an Arctic that in summer used to be like the image on the left, where you had sea ice that was covering the whole interior of the Arctic, even at the end of the summer melt season in September, to something like what we see on the right. This could happen, we're not exactly sure when, and maybe Don Perovich can answer some questions on that if they come, but something in the next couple of decades is the time frame that we're looking at for transitioning from an Arctic that is white, reflective, what people used to think of as stable, to something that's much harder to predict and blue and absorbing sunlight instead of reflecting it. So this is a major change. Never before in human history has an ocean opened up before our very eyes. So I'll be talking about the opening of this new Arctic Ocean. You know, what is happening to Arctic sea ice? I'll focus on the marine environment. There's a lot happening on the terrestrial environment, but my expertise and interest is on sea ice, and so I'll be focusing on that. What's projected to happen in the future? How can we adapt to the changes? What options do we have for mitigation? As Ross had mentioned, I'm really interested in connecting the science with policy and with action, and what are communication priorities and strategies? It's important to be thinking in terms of action, not just about adaptation and mitigation, but also how can we communicate? So this is the picture that many people have seen, and is something that is really very striking, very dramatic, and was also surprising. So if you take a look at this, this is the average monthly Arctic sea ice extent at September, running from 1979 to 2016. I first started working on sea ice in 1980, so right on the left side of this graph, and ever since I started working on it, it has not been good for sea ice because there's been a decline. What really caught our attention, though, in the sea ice community is what happened in 2007. And this was something that we hadn't expected. Of course, as the Earth is warming, as the atmosphere warms, as the ocean warms, it makes sense that you're going to be melting ice. But to lose something like 23% of the ice cover within that single season was just dramatic. It woke a lot of us up. In my case, it made me think, okay, what we need to do is we can't just be talking about what's likely to happen in the future. We need to start thinking about action at this point. What can we do to adapt? Because the trajectory we knew even back then, that is likely to be continuing to go down. And then what can we do to try to mitigate the changes, to try to reduce the amount of warming? So back then, I started thinking about what are the actions, and I'll be talking about some of those options here today. You can see that it just continued on. In 2012, we hit another minimum. And the projections are for this coming summer, things are not looking especially good, and I'll show you why. So in general, sea ice in September reduces back to its minimum extent. This is the summer sea ice extent for 2016 on September 10th. And you can see that the average, the median, from 1981 to 2010 had been this orange line. And so we had a much reduced ice cover. You can see that it's eaten away largely over in this side, the Pacific side, and then you have this patch here. Looking right now, this was just taken from the 18th of February, 2017. You can see that sea ice has expanded, and we're not quite at our winter maximum yet. The median ice edge is here shown in the orange line, and you can see that we have much less ice than usual here in the Barents Sea, in this region that's largely influenced by the oceans. So it's looking like the warm ocean water potentially could be influencing the ice distribution at this point. But this is important to remember that even in a future that has much reduced ice cover in the summertime, we're still likely for quite a while to have expanded ice coverage in the winter. It's cold up there, it's dark, so you're going to be freezing seawater still. And so even some people are thinking when they think of a blue Arctic, they're thinking that it will be there in the wintertime as well, and that's not true. What we're talking about is expanding the summer period in terms of open water. If we take a look at where we are right now, this is the current sea ice extent. Again, it's on the 18th of February 2017, so it's relatively updated. You can see this blue line here of 2016-2017 is below even what was our recent minimum of 2011-2012, and it's significantly below. So this is really troubling from a number of perspectives. First of all, it's low, which is not good. But secondly, because of the delay in the freeze-up of the ice, it's going to be much thinner. We're not going to be able to accrue the thickness that we usually get when we have an earlier freeze-up and we keep freezing over the course of the winter. So that means that likely we'll have a reduced ice extent to start with, potentially, but also it will be thinner. And it's much easier to melt through something thinner than it is to melt through something thicker. Now, the reasons for this are in part due to the warm pulses of air that people have probably been reading about, and you can see the anomaly over here on the left, together with some changes in the oceans in terms of warming. Sea ice is interesting in that it's floating on the ocean, so it's affected both from the above of the atmosphere and also from below in terms of the ocean. If you take a look at the Arctic record monthly low ice extents, they were set in 9 of the last 13 months. So January 2016 had a record low. February had a record low for that month. April had a record low. May had a record low. June, October, November, December, and January 2017. So this is really a dramatic change. This is really, even in the case of all the anomalies we've seen before, 2016 leading into 2017 is really something different. So to understand a little bit about what this means and what's likely to happen in the future, I'm going to show an animation of just daily images of ice. And I hope that that you're able to see this. These are satellite images, and it's daily images of the ice. What you'll see are some patches here in white, and these are the clouds. Try to focus on what's happening in the gray. That's the sea ice. So the animation will start. And, oops, no, it won't. Here we go. Here we go. OK. So what you can see, this is the North Pole, and there's not really a hole there. That's just because of the satellite images, but it's convenient because it helps to orient you. What you can see is the sea ice streaming out through here. Okay, this is the East Greenland Current, where a lot of the ice is exported out, and it's streaming out really quickly. This is the Barents Sea area that we talked about before as having the influence of the ocean, and the ice streams into it, but then is melted by the warm ocean water. So I'll just run it once more so you can see it. And you can see the ice, as it keeps moving in, it keeps getting melted back. What's really interesting is here in the archipelago that there's ice streaming through the islands here, okay? And this is something important to look at later on. Overall, there's a clockwise circulation of the ice, and this is because it's being driven by the winds. And so it's relatively predictable that that's the general pattern that you expect to see in the Arctic. So with this as a background, I'm going to talk about the sea ice thickness. As I mentioned, this winter, the ice is thinner than it usually is, and it's likely to stay thinner unless we have a dramatic change in terms of cold temperatures up there. You can see in the top right is what ice looks like usually when it's initially forming or when it's formed originally. It's often very flat. Here you see frozen lakes. It kind of looks like a frozen lake, and it's it starts out basically as a thin skin, and then it gets thicker and thicker and thicker over time. But as the winds start blowing it, it piles up, okay? And you form these ridges like you see here. And so over time, ice gets thicker for 2 reasons, so from year to year. One reason is that when it's being blown, you tend to get these ridges. The second thing is that you accrue ice on the underside as well. Every winter, you're adding more ice to the underside. So what I'm going to do now is show you an animation showing you the age of the ice, because you can kind of use the age of the ice as a proxy for thickness, because sea ice like us gets thicker as it gets older. All right. I know I've used that line before, but I like it. Okay, so here what we'll do, oops, it didn't start at the beginning. So you're seeing the punchline at the end. There it is. So this is ice that's 5 years old. So see all the red? There's a lot of ice that's more than 5 years old. So that ice is really thick. The blue ice is the ice that forms new that winter. So it's first-year ice, and that's thinner. And you can see over time, now right here, 1995, 1996, 1997, look at how much thinner or how much younger the ice is. 2000, 2001, 2002, 2003, 4, 5, 6, 7, 8, 9, 10, 11. Oh, there we go. So the final image that I have in this series is from 2015, and you can see that there's only a thin strip of this really old ice right here. So I'll be coming back to the distribution of the ice and the age of the ice when we talk about adaptation and what we can do about it. But right now, let's just talk about some of the projections for the future. So the projections for the future, as I started out saying, are that we are likely to have less ice. And the reason for this is, one of the reasons for this is basically the accumulation of greenhouse gases in the atmosphere, warming the Earth and causing the warmer temperatures in the Arctic as well as other places. This was a really neat study that was done where Dirk Notes and Julian Strove analyzed or plotted the cumulative carbon dioxide emissions since 1850 on this axis. And on this axis is the September sea ice area, those same plots that I've shown you before. And what you see is that as there's more greenhouse gas emissions, there's basically this linear relationship with less ice, the more greenhouse gases are in the atmosphere. And there was this quote from the former president of the Inuit Circumpolar Council, where she had talked about this back in 2005. You know, the Inuit hunter who falls through the depleting and unpredictable sea ice is connected to the cars we drive, the industries we rely on, and the disposable world we have become. So there's this direct connection between what we're doing here and what's happening there, because greenhouse gases are globally distributed. So this talks about this in terms of looking at the past about what's happened, but let's look at the future. So this is a projection from the Intergovernmental Panel on Climate Change. And what you can see is in black are the observed ice variations in September. And then you can see the projections for the future extending out through here. All of the projections are for lower sea ice. The one that seems to tail off at about our current level of RCP 2.6 basically is, if we could achieve that, if we implemented right now incredibly aggressive measures to reduce the amount of carbon dioxide in the atmosphere. That is not happening right now. So we need to look at all of these other scenarios. And what's interesting about them is that they all come down, not surprisingly, but then they tail off, and there's kind of this asymptote right here. So the question is, what's going to happen? How fast will this happen? In this case, they're saying potentially 2050 or so. Based on what we're seeing this summer and some other estimates, it could be that it's earlier than this. But what they also show right here is that there's this line which is called effectively ice-free. But it's at 1 million square kilometers of ice. So 1 million square kilometers of ice is an area about the size of Egypt. So what I'm really interested in, and we'll be talking about this in just a second, is where this ice will be and what we can do about it. This trajectory coming down towards this minimum is something that we are, all of the projections are that we're basically on this right now, and we're just not sure how far down it will go and how quickly we can turn this around. Now, why is this important? I mean, clearly within the Arctic, there's lots of reasons why it's important, and here we just sort of tabulating some of them. There's other reasons too, but within the Arctic, the sea ice provides services for wildlife habitat, subsistence hunting and fishing, coastal infrastructure support, intra-Arctic security, among many other services. The ones that are underlined are ones that I'll be picking up on. Globally, people hadn't been making this link so much before, except within some communities, but I think it's really important to know that globally the Arctic provides services for the rest of us. So planetary albedo. It's white, it reflects sunlight. Basically, it's kind of the refrigerator for the Northern Hemisphere. So when you don't have as much white surface, when the Arctic shifts from being white and ice-covered to having the dark ocean reflective, instead of reflecting sunlight, you're absorbing sunlight, which then melts more ice, which then warms it up even more. So you have this kind of feedback effect where you're constantly, the more ice you melt, the more you're warming. This is something that the Arctic has been providing as a global service to the rest of the world. Ocean circulation, it also basically is kind of like the lungs of the rest of the world. So the ocean waters from here, from the Gulf Stream, go up to the Atlantic as the North Atlantic Drift. That's actually the extension of that is that warm current in the Barents Sea that I said is melting the ice as it's coming in. When it gets up there, it gets cold, it sinks to the, and it's got a lot of oxygen in it, it sinks to the bottom of the ocean, and it comes back out in this big global conveyor. If you don't have the cold temperatures up there and the freezing, you're not transforming the ocean currents the way that they have been, and we could have disruption of this global conveyor. Carbon storage. The Arctic has a lot of carbon in it. In part, it's a carbon that's been stored for historically through the last ice age and from other times. The sea ice, focusing on the sea ice now, one way that the sea ice has been helping to store carbon is that it keeps the coastal areas cold, right? So near the land masses where you have all this frozen, where you have the permafrost and you have a lot of carbon stored on land, that's being kept cold in part because you have this sea ice right next to it on the coast. So it's keeping it cold, and that keeps the carbon stored and frozen instead of when the ocean warms up, it also warms up the coast, and you can have released carbon to the atmosphere. Atmosphere and weather, I'll be talking about in just a second, and also sea level. International security is another issue. So for so long, we've had the Arctic sea ice, which is inaccessible. It's difficult to transit, and so we seemed very far away from many of our neighbors up in the Arctic. And as you'll see, we're actually getting closer to the Arctic. So what are some of the within Arctic impacts of sea ice loss? The one that I'll just focus on is wildlife habitat and just related to sea ice. So just coming back to this graph here and just focusing in on this. What you can see here is most of the scenarios have some ice left for quite some time, and it's something between 1 million square kilometers and something like 500,000 square kilometers. So 1 million square kilometers is about the size of Egypt. 500,000 square kilometers is about the size of California, Madagascar, Japan. Okay, so it's still a significant amount of ice. So the question is, where will that ice be? So if it's patchy, if it's sometimes off the coast of Alaska, sometimes off the coast of Siberia, sometimes off the coast of Norway, then there's no way that it could sustain habitat for species in the Arctic. But if it's always going to be in the same place, then there's a potential that this habitat, this area, could be managed in some way for the future. And so we looked at that, and we'll start with the same ice age plot that I showed before. The reason for this is that this ice, as we said, the age is interesting because it's the thickest ice, right? So thick ice is harder to melt than thin ice. And the thick ice is here basically because the winds blow across Siberia and push the ice up against this coast here, this barrier, and it accumulates there, and it is much harder to melt than the rest of the Arctic. So this, based just on observations, if in the future the winds are still blowing pretty much the way that they have been in the past, this is the place that we're likely to have the thickest ice for longer. And when you take a look at the models, as I showed actually at the very beginning, the modeled projections are in the future, this is likely to be the place that will have the sea ice for longer than any other place in summer, after the summer melt season. So this raises some interesting questions. Here we know where the last ice is going to be. So, what are the implications of this? What does it mean for ecosystems? What does it mean for management? So taking a look first at the ecosystems, and of course, polar bears are going to be affected by all of this habitat loss that we've been talking about. What you can see here is kind of like the 24/7 grocery store for polar bears in the Arctic, which is a seal hole. So seals come up to breathe in these holes, and the polar bears come from all over. You can see all the tracks coming to that one hole. They wait there because they know sooner or later a seal is likely to come up in the breathing hole, and then they can catch it. Polar bears are pretty good swimmers, but seal are better swimmers. So it's really hard for polar bears to catch seals in the open ocean, but they can catch them here when the seals come up to breathe. The seals need the ice because they use it as a platform for their dens. They need ridged ice because the ridged ice creates, when snow blows across it, you have these drifts, and that's where they have their dens in these snow caves. So the seals come up, they breathe through the ice, they make their dens on the ice, and polar bears can also catch the seals there. And seals also have a convenient source of food in polar cod, which they find in the interstices of the ice. So the polar cod loves to be with the ice. It loves to be found in these small areas. When I was on one of the first expeditions I had up into the high Arctic, we had a graduate student his name was Nico Mum, I still remember it, and his goal was to capture Arctic cod and to analyze it. And he spent the whole expedition, it was like 2.5 months, trying to capture the Arctic cod, and he could never do it. He tried fishing, he tried nets, he tried everything. And towards the end of the expedition, I was out sampling some sea ice, and I found a little skeleton of an Arctic cod, and I brought it back, and I gave it to him, and he cried. It was the only one that he got on the whole trip, so because they really like to be in these small crevices between the ice. They don't want to be, it's really hard for them to catch. So anyway, there's this very tight association between the ecosystem and the ice. And if you take a look at the projected changes in the optimal polar bear habitat, it's not surprising that when you take a look at it, that all of those places that we know are projected, this is for 2050 or so, mid-century, all of those places that we know we're going to be losing sea ice are the places where the optimal habitat is going to be decreasing. There are some patches there in blue in other places, and those are going to be ephemeral, though, because as you saw in that satellite image, the ice is constantly drifting. So it's hard to sustain, ice cover in those areas. The one place where we see optimal habitat actually increasing is right in that area that we were calling the last sea ice refuge, but that has been renamed the last ice area. And it's right north of Greenland and north of Canada and the archipelago. The reason why that habitat is increasing is interesting, because in the past, the ice was so thick there that the seals couldn't have breathing holes, right? Because it was meters thick. And so now in the future, when the ice is thinner, they'll be able to have that mix of the seals with the breathing holes, they'll be able to make their dens, and then the polar bears will be able to catch them there. So looking ahead, this is important. This last ice area is important, not just because it's the last sea ice in the summertime, at the end of summertime, but also because it's likely to support this very diverse ecosystem that has been accustomed to the Arctic and that we think of when we think of the Arctic. Turning globally right now, so I'll just take up 2 of these. So first of all, sea level rise. So sea level rise, when we take a look at the projections for the future, they have a really wide range. So the reason for this is that there's 2 ways of thinking about glaciers. One of them is you think of them as like an ice cube melting on a plate, melting in place. And that's pretty easy to figure out, how much ice could melt under which temperature scenarios. And those are some of the lower projections here. But the thing is that glacier ice, just like the sea ice, is actually dynamic. So the ice actually moves. And so the question is, how fast will the ice start moving? How fast will we transfer ice from land to sea? So you might be surprised, here I'm talking about sea ice, and we all know that sea ice, when it melts, it's just floating, so it's like ice in your glass. When it melts, it's not going to cause sea level to rise. So what is the connection between sea ice and glaciers? So what happens is that the sea ice, which is currently around the coast of Greenland, basically keeps the area cold. And it also forms sort of a buttressing effect. So when it's in the fjords, it can hold the ice back, and I'll show you an image of that in just a second. But one of the big ways that the sea ice keeps the Greenland glacier stable is just the way it keeps the permafrost stable. You've got this cold surface nearby. It's reflecting sunlight. It's keeping the area cold. So it's keeping the ocean waters from warming, and so that keeps the glacier front colder, and so it's not likely to be destabilized. Here you can see some of the areas where the Greenland glacier is moving very quickly. So these are some of the regions where you have ice sheds that are sending ice basically into the Atlantic and Ocean over here. And here you can see one of these fjords, right? So you can see just how vulnerable the ice front is. If that ocean is warmer there, then you can melt the front. It can actually lift off. Many of these ice fronts are grounded right now. It can lift off, it can destabilize, and it can transfer more ice from the land into the sea, and that's what causes sea level rise. So this is one of the big questions looking ahead, is just how the dynamics of the Greenland ice sheet are going to play out in the future, and so how much will sea level rise. Another thing that the Arctic has been doing up until now has been having this, as I mentioned before, we have this, the albedo, the white surface in the Arctic, has been keeping the Arctic temperatures colder. When we start warming the Arctic, we have the potential to destabilize the jet stream. And the way that this works is like this. So you can see this really cool animation showing the jet stream. Right now, the jet stream speed and position is governed by the gradient, temperature gradient between the warm tropics and the cold Arctic. When the Arctic is warmer, so when you have a really steep gradient, when you have a big temperature difference, then the jet stream moves quickly and it has less of these meanders. When you slow it down, then it starts meandering, right? And so this is what people have been talking about in terms of the polar vortex. You know, the jet stream kind of having these big loops. And this is something that is projected to increase in the future. Right now, we're kind of trying to assess the signal versus the noise. But looking ahead, this is something that's likely to continue in the future with these really wild weather swings. So how can we adapt to these changes? So we're going to talk about adaptation, mitigation, and then communication. So one of the things that will be happening, and this is an image from the US Navy Arctic Roadmap. They did a projection analysis from 2014 to 2030, but then also looked beyond 2030. What they put on this map, what they thought would be of interest, is where the shipping routes might be. This is the northern sea route, shown in red, a transpolar route that could open up for the first time, shown in green, and then the Northwest Passage, which people here probably know a lot about, shown in blue. Their images here, you can just see their outer one. I'll read off the numbers because it's hard to see in the back, is 2012, 2020, 2025, and then 2030. They're expecting the ice to be in this location, basically because, as we said before, the wind's blowing the ice over, and this is the last ice in September. So the projection is that looking ahead, we're likely to see more shipping, and that's already been happening now along the Northern Sea Route and in the Barents Sea. How much shipping we're going to have is a question. For a long time, the Arctic is going to be unpredictable or less predictable. It's going to have big variations from year to year. Shipping relies on having stability. We haven't charted the bathymetry very well along the coasts in many of these areas, so there's just a lot of questions. But talking to insurance companies who have been asked to potentially insure the ship's shipping fleet going up through the Arctic, they basically say it's not a question of if, but a question of when there'll be a spill. When will there be some kind of accident, either that needs search and rescue or that releases contaminants into the Arctic. And so this is something that, as we're thinking about increased shipping in the Arctic, this is something that we need to be prepared for, is a potential for contaminants to get into the Arctic, and how are we going to deal with them. Another one is the oil and gas wells and lease sites. And these are largely, have been largely on hold, in part because of the difficulties that, for example, Shell encountered when trying to look at the sites up in the, actually I can do this, right? In this area here. What's interesting now, particularly right now, is that these polygons here are all part of the Exxon-Rosneft arrangement, where Exxon was working with Russia on, these are their lease sites, where they're potentially interested in developing. And Exxon has invested a lot of money to work with Russia on these. They're all off limits right now because of the sanctions over the Ukraine, but we don't know what's going to happen with that in the future. The problem is that when oil gets into ice, it's really hard to deal with. And in fact, when it gets into the multi-year, the ridged ice, it's basically impossible to deal with. When you have thin ice, you can use something that has kind of a scrubber on the front, and they use that in the Baltic to kind of sweep up the ice, the oil. But when you get into this, this complex environment, when the oil can be on the ice, between the ice, under the ice, it's just really hard to clean up. And some recent research by Bruno Tremblay shows that when oil, say, gets into the ice, it gets transported faster than with the ocean currents, because the ice drifts with the wind more quickly, than the ocean currents can move. So we're concerned about, what can happen, if we start developing in these areas, what could be the potential for contamination. So one of the things that we've done is we've developed this thing that we call LITS, which is the Lagrangian Ice Tracking System. And this is publicly available. You guys can go online, and it's a little bit glitchy, but it's kind of cool. And you can actually try running these yourself. So what you do is you put in a start location, and you can either click on using a mouse on the screen, or you can put in a specific start location. You can put in a year, a start year, and you can put in an end year. So what I did in this case was and this is based on observations. It's based on satellite observations. So these are not modeled projections. So what I did was, just for 2010, I said, what if there was an oil spill in October just north of where the Exxon Rosneft oil leases are, and lease sites are, and these are the trajectories of where it would go. So it goes straight across the Arctic, right over the North Pole. Some of the ice would exit over in the East Greenland Current that I showed you before in the satellite image, but some of it would come right into this area here, the last ice area, right? So we decided to take this one step further, and really thinking from a development perspective, we could do this for individual locations, but what if we take a look at the exclusive economic zone? So the exclusive economic zone is the region over which the different countries have jurisdiction, and they can exploit and explore within those areas, basically, within some limits, but it extends out to 200 nautical miles. So what we thought we would do is say, okay, taking all of the ice that forms in these regions, where does it go? So now what I'll do is I'll start this animation, and you'll be able to see. So the Russian ice is in red. The Norwegian ice is in purple here. Greenland ice is in a darker purple, and the Alaskan ice is in blue. So you can see, first of all, that the Russian ice is basically, Russia forms a lot of ice. It's called the ice factory for the Arctic. So the Russian ice is extending down here. You can see that it's flooding into the Barents Sea, so that it's flooding into the Norwegian areas, it's flooding into the East Greenland area. And increasingly, look at this route coming across the pole here. So at the very beginning of the animation, not much ice went in that direction, but look, it's continuing across, and you can actually see this small bit of ice that's still over there, right in the last ice area, exactly where our Lagrangian tracking system indicated that ice would come if those oil lease sites wound up with some kind of spill. So now what we can do is we can, let me just take it to the next one. So we have this database, and so what we can do now is we can actually quantify it, and we can look at how long it takes for ice to move from one exclusive economic zone to another. We're calling this transnational ice, okay? So it's ice that forms in one country's exclusive economic zone and melts in another one. So the longest time used to be Russia to Canada. So at the very beginning of that animation, it would take something like 12 years for a Russian ice to get to Canada. The time has basically been cut almost in half. The central Arctic to Canada also cut almost in half. And this is the pre-2000 and to the post-2000. When you look at the data for more recent ice transport, it's even quicker than what you're seeing up there. Central to Alaska, central to Greenland, Russia to Iceland, Russia to Greenland, all of these, the transit time has been cut almost in half. The ice is speeding up, right? So the countries are becoming closer to each other in terms of timing. The other thing that's happening is that the aerial flux, the actual amount of ice, is also mostly increasing. So the amount of ice moving from Russia to Norway, that big flux that I had showed to you, has increased. Alaska to Russia, central to Russia. Canada to Greenland has increased a little bit. Russia to central, and central to Greenland. So there's actually, the amount of ice is actually increasing. And people say, but there's less ice, how can this be? What the ice that is forming is more mobile. So what's happening is because it's thinner, because there's less of it, it's really easy for the ice to move with the winds. Whereas in the past, it would get stuck because there'd be so much other ice around and it would be so thick. Here's another way of looking at this. In the pre-2000, 1988 to 1999, you see the ice in red. And the distance traveled is on the x-axis, and on the y-axis is the total ice area in kilometers squared per year. So it used to be that the ice basically, on average, that any ice that would be exported from an exclusive economic zone would transit about 1,000 kilometers. And now it's transiting 2,000 kilometers. So it's circulating around to a much greater extent. Taking a look at the specific area of interest of this transport of ice from Russia to North America. So this is Greenland, Canada, and Alaskan waters combined. It's basically gone up by something like a factor of 4, the amount of transport that's coming straight across the Arctic from Russia to North America. So what this says to me is that we need something like a sea ice management plan. We need to be thinking about the sources of the ice and where it's coming from and what we're doing in terms of development. We can think of it like an ice shed, just as we manage a watershed, right? You could think of managing the ice shed so that we understand what activities are happening, what shipping routes are happening, what oil and gas development is happening. So we're aware of what the potential is to impact some critical regions in the Arctic. So this was just one example of what we had shown in terms of an ice shed. And you can see that it extends all the way over to Siberia. In the future, though, this is based on observations so far. In the future, as we continue to have less and less ice, this is likely to change a little bit, because it could be that the ice, instead of drifting across in a couple of years, is exported from Russia and then melts in the middle of the Arctic, right? So the ice shed is likely to change. So any management plan is going to need to take into account not just that the location of the refuge itself would be shifting based on the winds and the ocean currents that year, but also how the ice speed is changing. And another thing is, so we used to think that this last ice refuge might stay there, last ice area might stay there for decades longer than the rest of the Arctic. But of concern is the passage of ice through the archipelago here. So some of the higher resolution models look like the streaming of the ice through the archipelago. If the ice is thin enough and mobile enough in the refuge area, it could actually stream through rather than being blocked. So this is another source of uncertainty that we're not exactly sure about, but I think that it's important for us to be looking at this because we now know where there's a scientific consensus of where this is going to be, and it is a critical habitat, sort of like the Great Barrier Reef or maybe the Galapagos. So way back in 2008, right after we saw the loss of ice, a couple of us had said, what we really need is maybe a World Heritage Site for ice. And that is indeed, there's a proposal currently underway for a World Heritage Site for this region. So it'll be interesting to see how that works out. So that was just one example of how we might adapt. What I'm going to do now is turn to mitigation. So mitigation, by mitigation, I'm thinking about, what can we do to reduce the amount of warming and potentially even cool the Arctic. So if you take a look at the schematic here, we have the business as usual. And this is this graph that you're now familiar with about the sea ice loss. We'll dip down. We're thinking somewhere into this area of 1 million square kilometers or so. We're not really sure, but that seems to be a projection. Or many of the models project something like that. Can we turn it back around? Can we, before we lose the last ice area and the habitat there, can we actually turn the temperature around? So this was we held a workshop called White Arctic, Blue Arctic, Restoring Arctic Sea Ice, ? I think. And Don actually was able to join us there. It was just great, Don Perovich. And we talked about what the timescales are in terms of what the best projections are for sea ice loss, how it's going to respond to warming, and then what are the projections for how we could ramp up mitigation. So what we're thinking of in terms of mitigation is carbon dioxide reduction, emissions reductions, but also carbon capture and sequestration. So all of the, and this was before Paris, and all of the agreements in Paris too, if we're going to stay to the, 1.5 degrees of warming, which the small island states had said, is really critical for their sea level rise, or even less than 2 degrees, we're going to need to engage in not just alternative energy implementation and increases in energy efficiency, but we also need to start taking actions to remove carbon dioxide from the atmosphere. If we don't engage with that, scale it up on a large scale, then what will happen is that through alternative energy and efficiency and for example, uptake of carbon dioxide through increased planting of trees or stopping deforestation, we could still, at some point, turn the temperature around, but it will be so far in the future that we'll have lost lots of the Arctic services that we are depending on right now. So to turn it around quickly enough that we can retain the Arctic services intact, we need to engage on something like this on a large scale. The National Academy of Sciences did a study also where they looked at solar geoengineering, solar radiation management, ways to actually increase the white aspect of the Arctic, kind of to replace what's being lost with increasing reflectivity. This is not something that I'm advocating. I just want to let you know that the National Academy of Sciences thought that the changes are so serious that they said, look, we need to be doing some kind of research on this to know potentially what our options are. But to come back to this curve here, so one of the interesting things in looking at this that we realized after talking about it in this workshop is that, with the ice coming down to this low ice scenario, the time scale to actually turn the temperature around, not just to stabilize temperature, but to cool it enough, right, so that the ice can come back. Because it's not magic. If the Arctic were colder, we would have more ice. So there's a direct relationship with that. So if we could cool the Arctic, then the issue is that it looks like there's going to be something like 1 or 2 generations that have only known a blue Arctic in summer. Right? So they'll be in a situation not like we are right now, where the Arctic that we know of is changing in front of us. They'll be in this situation where maybe, for some people, all they will have known is this, an Arctic that in summer has this very reduced ice cover, and that's what they're experiencing. So it got us to think about, this generation here and thinking ahead to stakeholders and who would actually want a white Arctic and who would want a blue Arctic. And in doing this, we realized that there's a lot of people who are on both sides. So Arctic residents are on both sides, right? There's a lot of places in the Arctic that are incredibly have really difficult situations. They're having to make choices between energy and food, and sanitation is difficult. So a lot of people in the Arctic are saying, and a lot of, especially in Greenland is one example, they're saying, look, we really want to develop the resources that we have. And the blue Arctic helps us do that. And on the other hand, there's this incredible cultural heritage, the ways of life. There's lots of reasons why the white Arctic, subsistence hunting and fishing, right? Tourism is also kind of on both sides. Tourists want more access to areas, but the tourists also want to see, the white Arctic as it's been. Fisheries. Many fisheries are moving north right now, so some areas are having booming fisheries, whereas other ones are losing fisheries. In the future, we're not exactly sure. I keep checking the literature on this to say, what is the latest word on it? And the main thing is that there will be change, and whenever there's change, there'll be winners and losers. So fisheries are on both sides. Environmental groups, I think I can place on the white Arctic side. Oil, gas, minerals, I think I can place on the blue Arctic. Shipping, probably on the blue Arctic. Global coastal communities facing sea level rise, they need the stable ice in the Arctic. They need the stable cryosphere. Global society, temperature maintenance, and also Northern Hemisphere residents with weather. They would all potentially be really interested in restoring the White Arctic. So we held, and then I have inertia, existing infrastructure, because that's kind of what we've been doing up to now, is we've been kind of moving along, with inertia, kind of not making overt decisions about what direction we're going, but this is kind of the trajectory we're on. So we held a workshop recently where we actually looked at what would happen if the Arctic were at 2 degrees, something close to Paris, and the Arctic would be 5 degrees warmer. So this is a very different Arctic. I mean, already we're seeing the problems that we're facing with the temperature changes thus far. One of the things that we came out with as a recommendation is that we need some kind of Arctic coalition, because we need for the Arctic to have a voice in negotiations. The problem is, as we just showed, is that there's such divergent voices within the Arctic right now in terms of stakeholders, different countries, but different, even within communities, there's some sort of split perceptions and opinions. So, but the model for this is, the Alliance of Small Island States had an incredible voice in Paris, and they were able to really affect change. And the Arctic, with all of the changes that are happening there, both for within the Arctic community, but also the global implications, should have a voice in communicating about these issues. So I'll turn now to communication priorities and strategies, which is my last part. So as Ross had mentioned, I'm the PI for the Polar Learning and Responding Climate Change Education Partnership, which we just abbreviate as the Polar Partnership. And our goal with this is to inform public understanding of the changes in the polar regions and also how to respond to them. We're developing novel educational approaches, and we're trying to reach adults like you guys. And one of the reasons for this is that about 1 in 5 Americans are in a formal educational setting, and many people who are not in a formal education setting did not learn about climate change when they were, going through school. And so we need to find some way to engage with people who just have not had the chance to be, to have the formal education on this. And so we're looking for these novel approaches where we can catch people, museums, on cruise ships, on other places of opportunity where we can engage with people and talk with them about the issues. It's a large partnership. It's funded by the National Science Foundation. We have many academic institutions here, including Larry Hamilton at the University of New Hampshire. We're also working with education practitioners, the American Museum of Natural History, the Museum of the North, and the Association of Native Interior Educators. And then we're also connecting to some degree with industry and with some, like, for example, Games for Change, where Mary Flanagan often speaks, and Autodesk, which is a main producer of gaming software. So with this partnership, we're trying to think about, what are our communication priorities, and then also what are our tools for helping to engage with people or to provide information to people on these. And what I'll do here is just give a couple of examples. This also comes from our recent workshop about the priorities coming out of our 5-degree Arctic and a 2-degree world workshop. So we had one category that was adaptation, and then another category, not surprisingly, that's mitigation. So I'll give you a couple examples of adaptation and then also mitigation. So one of our communication goals is that within the Arctic, habitat is going to change. So this is that whole chain of how polar bears are affected by seals, which are affected by polar cod, which are affected by ice algae, so it's that whole Arctic ecosystem. When many people Google global warming, a polar bear pops up. But climate change is not all about polar bears. So we wanted to let people know about the cascading impacts along the entire food web. We also want to help people to understand that humans are a part of this and will be affected. And we also wanted to help people understand what they can do to help. So we created this card game called EcoChain's Arctic Life. And basically, you create a food web, you have an ice dependency, and then events happen like carbon pollution that melt your ice, but you can bring in alternative energy resources, and you can actually bring ice back. So people play this game, and they're stewards of their marginal seas, and they get really invested, in their ecosystem. And when something happens to disrupt it, it's concerning to them. But what's really neat is that when you play the game, you actually learn strategies for how to play your cards right for a healthy Arctic. Right. So the other thing that's really neat about it is that we've done research on it, a controlled study, and we found that there was actually better learning by playing the game than by reading an article. So we randomly assigned people to either play the game or read an article that was tweaked to have the same content. We surveyed them initially, and we asked them, what species come to mind when you think of the Arctic marine ecosystem? And it's polar bears, seals, and penguins. Penguins aren't in the Arctic, okay? They're not in the Arctic, okay. After they played the game or read the article, we had them now say, what species did you learn by playing the game? And they talked about, krill, algae, phytoplankton, humans, no penguins, right? So we achieved something. The really cool thing was that there was no statistical difference between the ones who read the article and the ones who played the game. So for me, that was a victory already, because people say, oh, well, games are fun, but do you learn anything? So the game was able to teach just as much content immediately afterwards. But the really big thing that was really neat was we did a 4-week follow-up study. And that's what's in the lower panel. So on the right, the ones who played the game, we still asked, what were the new species you learned by playing the game? They have the same colors, phytoplankton, algae, krill, and then polar bears and seals come in here. Clams, walrus, and humans, right? These are all ones that they said that they learned by playing the game. So they did revert back to some degree to polar bears and seals, but look at this. The ones who read the article, they just had their initial perceptions reinforced. Look how similar that is. That was their immediate reaction. Then they also, secondarily, they brought in the algae and the human beings, but it wasn't their first reaction and their most numerous reaction. So this showed that basically that the learning was stickier when they played the game than when they read the article, which was really neat. The other thing is that people who played the game had an increased perception that they knew what to do to help out, whereas the ones who read the article felt less in control. They knew less. We think that they got kind of frustrated and overwhelmed with everything that was there. And even better, I think, is that it maintained their interest, they lost track of time, and made them feel happy. This made me feel angry. So the ones who read the article felt angry, but the ones who played the game felt less angry. So what we think is happening is that because they're actually able to play the action cards and they're able to see that there's things that they can do to help, that it actually connected with a sense of personal efficacy, which research has shown is likely to lead to positive behavioral steps. Another communication goal we have is that within the Arctic, there's multiple stakeholders with multiple perspectives, right? So that was those charts I showed about who would like a white Arctic, who would like a blue Arctic. So we have this game that we call Arctic Smartic, strategic management of resources in times of change. And people play roles, and they're tasked with developing a multi-use management plan for 2050. And it's really neat. They play an oil company or fisheries, and they have to identify areas of high priority interest. What we found is that it's fun, so games always have to be fun. So this group up there was on a tourist ship, and they were playing it. And when we did follow-up studies, what we found was that people felt that it's really complex, and it's easy to become kind of lost in the sea of complexity. But by visually mapping out the interests of all the different stakeholders, they were able to see that where conflicts arose, and then they were actually able to negotiate management plans to resolve the conflicts. And it's neat because people bring in their prior knowledge, and they're able to bring that to bear on the negotiation. And many people, after playing the game, feel more hopeful about actually working out solutions. Another communication goal is the global impact of sea level rise. So this is something that is frustrating to all of us who work on ice. So if you look at what would have the greatest effect on sea level if melted, 31% say Arctic sea ice, which, as we know, is not going to raise sea level, right? And 31% say it's Greenland and Antarctic and land ice. So basically, people are guessing. They just don't know. So we have an app for that. It's called Polar Explorer Sea Level Rise. And what's really neat about this is that people access these databases of Arctic sea ice, or Arctic land ice, and they are able to explore it and find out who's vulnerable from sea level rise. What are the main glaciers that potentially could melt? And it's free, and you can download it. Polar Explorer Sea Level Rise. Another communication goal, I'll sort of end on a happier note here, is we talked about the weather, and we said that there's likely that the warming of the Arctic is likely to destabilize our weather systems. People already, surveys show, 65% of people feel that weather changes are an important problem now caused by climate change. So that's a large number. And there is bipartisan response to this. There's differences, of course, but there's significant numbers of people on both sides that responded in the same way. I won't talk about this here, but health is also really high. And we asked the question about happening now caused by climate change. Sea level rise does come up more in the questions when we said about in the future. What's interesting for us with respect to the Arctic is that this was an earlier study that was done in 2014, and this said, how much do you agree with the statement that Arctic warming will have major effects on weather where you live? So this connection between the warming Arctic and the weather, we think, is embedded in people's responses to the previous answer because it's very similar numbers. And what was particularly interesting about this one was it was either cold snaps or warm snaps that cause people to think about weather. So people are not just thinking of the warming of the Arctic with warming temperatures. They're also thinking of it with the cold snaps that we've been having. So they have this mental connection in mind about how the Arctic is connected with that. And then finally, the last communication goal has to do with mitigation. And we talked about the fact that we need to switch to alternative energy resources along with taking other steps like carbon capture. But again, renewable energy comes up right now in a bipartisan way, and this is not the only study to show this, if we say what is needed now to reduce risks of climate change. And so I think people are really interested in alternative energy. So looking ahead, over the next several decades, we'll be dealing with our legacy. We're heading towards a largely ice-free Arctic, but not entirely, which is really important at the end of summer. The exclusive economic zones are increasingly interconnected by faster and more extensive ice flux. There's increased interest in fisheries, oil, gas, and minerals. The Arctic Council is, of course, it's the Arctic Rim countries who get together in the Arctic Council, and they're recognizing these changes, and it's really neat that they formed a new task force on Arctic marine cooperation, and they're expecting to have recommendations within maybe 2 or 3 years. There's also a joint Finland-US education summit that will be happening in the same time frame. And so within the Arctic Council, there's a couple of activities that are happening that can help us address some of these issues. Looking ahead, Julia Rosen wrote this article as a feature in the journal Nature called Arctic 2.0. So Arctic 2.0 is our choice, What do we choose? What do we want? What are we going to head for? A future with or without ice. The ice provides all of these services that we all depend on, and we haven't realized just how important the Arctic is, I think, to our day-to-day life. In order to bring back the ice, we're going to need to invest heavily in decarbonization. And I thought this statistic was just really cool that wind surpassed hydropower dams to become the largest source of renewable electricity capacity in the US just recently. And most of this, or a lot of it, is in Texas. Texas is really big on renewable energy. And so I think that there is a path towards the future in terms of reducing our emissions of greenhouse gases, in part through changing our energy sources. Will we invest in carbon capture? Carbon capture, again, it's something that reflects ingenuity and problem solving, potentially in jobs, and potentially many of the large oil and gas companies that are currently associated with the large emissions that we've had over the past. Historically, they could be well positioned actually for some of the approaches to carbon capture in the future. So we could potentially be matching up some of the big emitters with potentially a solution. So looking ahead, I think that it's really our choice right now, and it's a choice of what we decide over these next couple of years, decades. Of what is the Arctic that we're going to have for the future. Will it give us the Arctic that the world needs? Or will it be some other kind of Arctic that we just let happen in front of us without taking it within our control? Thank you.
recording this, so you can also follow up on this, share with your friends and colleagues. So, questions? Mike's coming.
I didn't want to make this the first question, but but I'll ask it now since there weren't any others. I'm curious, and maybe it affects the response somehow of man to the situation. How much of the current warming trend is due to natural changes in the universe, like ice ages come and go, versus man's influence?
Right. So historically, we've had the ice ages, that have been steered in large part by changes in solar insolation, related in large part by just our Earth orbit. So it was something external to the Earth. Our sort of planetary arrangement, shifted. So that was largely what was steering the ice ages, and we've got a pretty good handle on that. What's happening now is that we've rapidly increased our emissions of greenhouse gases, and that's something that you can basically, as you saw in that graph, the more the greenhouse gases are in the atmosphere, the more melting of sea ice we're going to have, the higher the temperatures are. So this part that we're looking at right now is largely anthropogenic. What's happened in the past was due to natural changes that were largely something outside of our actions, and now it's due to our actions.
So we're not in the midst of a natural warming trend.
No, we're not. Yes, and I can just the graph, looking back through time is something like this,
Right.
Not exactly, and it comes up, and we were in this stable warm period, which was an interglacial, and this is the levels of greenhouse gases. Right now, our temperature is right here. But in the past, I should have colored chalk. If you took a look at the temperature correlation with greenhouse gases, it's just amazing how well correlated it is. So we're expecting that we're going to be coming up basically in line with the emissions. Yeah.
Thank you.
Yep.
The Russians are a big part of the Arctic. What's their general attitude? Is it much the same as ours in terms of how they see the future, or are they struggling with policy issues just like we are today?
Yeah, so it was interesting because just a little while ago, there were some statements that had come out of Russia saying, we're going to, the Arctic is hard. You've got ice. It's cold. There's lots of reasons why it's hard to develop the Arctic.
But they have attractive resources there as well.
Exactly. So they said, hey, we're going to develop our other resources first, right? But now, things have changed, and they're actually looking more to the Arctic. They're looking more to the Northern Sea route. They are installing more infrastructure along the Northern Sea route, and in part, this is in hope that there'll be shipping that they can actually get some, profit from, as well as supplying to their communities up there. But also, there's increasingly concerns are that they're also doing that from kind of a security perspective as well, So Russia has a lot going on right now, and as you could see in those images, it's a huge part of the Arctic, and it has disproportionate influence, not just because of its coastal size, but then, as you saw, the sea ice that is formed there is just basically flooding the rest of the Arctic as well. Yep. Okay.
I heard this morning or a day or so ago, something about measuring CO2 very close to the ground or to the ocean, and there's a sense of its impact on acidification of the ocean and so on, and we don't hear much about that.
Right.
So
right.
What are your thoughts?
Yeah, so ocean acidification in the Arctic is a big issue, and it's a lot of concern. The food web in the Arctic is simpler, and so if you destroy some species or if you impair them. So for example, walrus eat clams, and clams are subject to, if there's acidification, they have calcium carbonate shells, and so they're going to be dissolving or be under stress. It's a really straightforward food web, and so you could dramatically impact different parts of the Arctic through ocean acidification. This is something that again people had proposed this solar radiation management. And one of the arguments against that is that, if you artificially, I feel silly even talking about it, but put up bright surfaces in the sky or make the clouds brighter or something like that, you're not doing anything about the carbon dioxide levels. So the carbon dioxide in the atmosphere will still get into the ocean, and you'll still have ocean acidification, even if you do something like that. Yeah. So the Arctic Council had actually, they were so concerned about ocean acidification that they actually had a task force that looked into it, and they issued a report. And it's something that the Arctic countries are really concerned about, and it's something that people should be talking about more. You're right. Yeah.
You spoke about the amount of ice that will melt and sea level rise, and this is a two-part question. Do you have similar ranges of that we read about? How much can that, it's hard as a mechanical engineer
Right.
to see how much water could exist
Right.
above land, right? All of it has to be above land?
Yeah, all of it has to be above land. So I can ask Mary Albert to answer this question, maybe. but I'll take a stab at it first. So we know really well, I think, how much ice we have on land, right? Yes. Okay. So the question is, how much of it can get into the ocean, and over what time period? So in Greenland, I think the estimate is, so there's something like 21 feet of sea level stored in Greenland if all of the ice were to melt. But not all of that is easy to get into the ocean. To slide into the ocean along the mechanisms that I talked about. So maybe something like a third of it is relatively vulnerable to some of the issues that we've talked about here about flowing into the ocean relatively fast. So the estimates of what is on land and what effect it would have on the ocean if melted are really well known both for the Arctic and the Antarctic. We have that inventory, but the question is more about how quickly it can move from the land to the sea. Yeah.
Second part of the question was that, is anybody thinking about the idea I had flying over this area? It appears to me there are probably 8 major rivers coming out of the glaciers of Greenland. Those dams wouldn't have to be too large to keep it there for as long as we might want. If you dammed those up, keep that fresh water to send by boat to people who need it.
So dam the rivers on Greenland, of the water running off, and then let it freeze the following winter?
Well, that first, but if it continued to melt, it becomes a big lake, and use it where you want it. Maybe you get some hydroelectric out of it as its way out.
So one of the really cool things about, well, I shouldn't say cool, well, it is actually. So I actually studied surging, fast-moving glaciers for my PhD. And what I was studying was there was a meltwater outflow point. And what had happened was that there was a pond on the glacier. And it actually melted its way, permeated through cracks into the glacier. It's called a moulin. And it tunneled all the way down to the base of the glacier. So the water doesn't just flow on the surface. It actually gets down to the bottom of the glacier. And it then flowed along the bottom of the glacier, kind of in a river, and it came out in this meltwater outflow point. So I think that if you tried to, kind of dam the rivers and try to maintain it, which would be relatively hard to, I think it would be a challenge, it would still find its way down. It could find its way down to the glacier from another way. But Mary wanted to answer the previous question, I think, about sea level rise. You could answer this one too.
Yeah, I just want to make a plug for the federal agencies, the NOAA, NASA, USGS, Corps of Engineers have a website called climate.gov. So if you go on to climate.gov, you can look at what they call the Climate Resilience Toolkit. And using your own computer at home, you can go on there and see how much sea level will rise in your area in the coming years. So it's mapped out, there are tools, it's free to use, easy to click on. So climate.gov, the Climate Resilience Toolkit, is not only tools for sea level rise, but tools for adapting and mitigation wherever you live across the United States.
Question from the other side of the room here. I know you're kind of cut off. We will get a mic to you. Oh, we have a mic. Great.
A couple of questions. One regarding the northern sea route from the Bering Strait to Murmansk or vice versa, across the north of Russia. I understand that a little over a year ago, the fall of 2015, the first fully loaded cargo ship, first container ship, made it from China to Rotterdam with some help from Russian icebreakers along the way. And the Russians, you ask a Russian, and it's not a question of maybe, they say it's going. And I believe that the facts may show that since the ships are going back and forth several a year. And the other questions about possibility of the cold water that's coming with all the melting, flowing down on the west coast of Greenland, the rivers that you spoke of, and coming out the south of Greenland, impacting the Gulf Stream, which make a slight, but slight could be enough, cooling, so that within a warming world, there may be the Western Europe Peninsula may have several decades at least of cooling.
Right. Yeah, actually, the president of Iceland, I think, at one point was concerned that that Iceland could actually cool for exactly that reason. The northern limb of the conveyor belt that I talked about kind of getting shut down, and so instead of bringing the warm water up, it was cooler. And actually, some of the modeled projections for the future show less warming in that region for exactly that reason. About the container ships, so one of the things is right now that the container shipping is so optimized in terms of knowing exactly the transit times, how much they can carry, how much fuel it takes for this, and everybody's trying to get the prices down so low that many people are thinking that an Arctic route where there's so many questions about timing it's not going to be economically viable for the normal cargo. For cargo that does not have time constraints and is potentially, really high value, that potentially could be moving through the Arctic. But it's one of these things that at the beginning, we're going to be seeing these really big variations, and so I think it's really going to be. It's hard for it. It'll take a while for it to become stable enough that it's something that companies can rely on. There's a lot of interest in it. And there definitely will be more within Arctic, or like Europe to Russia, Alaska, transiting. The question is, does this really become this global shipping route? And it will take quite a while of being pretty secure about the ice conditions before it looks like the shippers, the big shipping companies will want to be using it on a regular basis. The other thing is it's going to be seasonal. So at first you'll have like 1 week in summer that's reliably ice-free, right, or something. Then 2 weeks, 3 weeks, 4 weeks, 5 weeks, 6 weeks, 2 months. It's going to take a really long time until the entire winter is open. So you also need some kind of cargo that you can be shifting, seasonally up to the Arctic to take advantage of it. So it's more complex than it seems at first. Yeah.
Thank you for a very interesting talk. Many of us are familiar with the concept of the carbon budget under which a certain amount of fossil fuels needs to be left in the ground. Would you agree with the article that was published in Nature a couple of years ago that when it comes to oil, the first oil that would be sacrificed or left in the ground would be Arctic oil? In other words, do you think the science drives us to end oil exploration in the Arctic?
What I'm hoping is if we take a look at this, I guess it's too far back, but if we take a look at the increase in alternative energy, right? That I feel like what I'm hoping is that will grow so quickly that the need for these other resources are not needed anymore. And right now, there's no need to be developing Arctic oil, right, and gas. So potentially, just in terms of to power our economies right now, we don't need to do it. So I'm hoping that as we ramp up, the alternative energy sources, the demand, the need for more oil and gas will actually be diminishing, and it will become kind of a moot point.
Yes, thank you for an interesting lecture. I'm just curious, would you confirm something I read a while ago? As we all know, Florida is fairly low-lying, and I believe the Mar-a-Lago estate is among those areas that are threatened. And in fact, I believe, or at least I read, that Herr Trump applied for and received a federal grant to build a wall around his golf course to mitigate the threat of rising sea level. Is that indeed the story as you know it?
So, I don't know the details of that story, but I can tell you one thing, that one of the, when we're talking about communication and communication priorities, making the link between the, the sea level stabilization services, that the Arctic provides, right? And what could impact the rest of the world is really important. And so some people are talking about, if Greenland goes, so does Florida, right? So making that direct connection, and as we talked about with sea level rise, So, we need to be thinking about communication strategies. It's really important, and especially, as you point out.
Well, my follow-up question, of course, is do you think that this apparent recognition of the effects of climate warming actually portends some acceptance of the fact by an administration that appears to reject it, almost in its entirety?
Yeah, I don't really know. I mean, businesses, many businesses are saying we need a price on carbon. We want to be, for global competitiveness, we need to be doing something more in this area than what we're doing right now. And so there is a business case from many perspectives in terms of, increasing resiliency and being better prepared for the future, but then also competitiveness. So I think that the way that the business interests wind up playing out, I'm not exactly sure, but it could be that those voices within the business community who want to be moving more aggressively in this area might win out. I mean, one thing to think of with the Arctic is that the oil and gas up there becomes more accessible the more warming that there is, right? So that's another business perspective as well that kind of comes from the other side.
Well, Stephanie, I'd like to thank you for, I think, certainly one of the most comprehensive and passionate informative talks we've had about the Arctic. And obviously, we'll be asking her back for the fourth visit.